Audio Jungle. Audio Jungle.
So this is next problem. Now the question is, draw SFD and BMD. Draw SFD and BMD for double side overhanging beam subjected to loading as shown below. Locate points of contraflexion. Flexor, if any. I had explained what is the point of contraflexor in theory part of the SFD and BMD. Now coming to the beam. So this is the beam. For this particular beam, we have to draw the SFD, BMD, and we also have to check is there any point of contraflexure. If any point of contraflexure we have to show that also. We have to find that point. The point of contraflexure is the basically point where the bending moment diagram will change the sign. Sign means from positive to negative or negative to positive. Like in previous problem we had seen, bending moment diagram was not changing any sign, it was only positive side, so there was no point of contraflexure. Okay, this is the beam. This is called overhanging beam, right? This is called overhanging beam. Here it is also mentioned now, overhanging beam. Yes, this is because this part is what overhanging, because support is what here only. This is the support now at this point. So this power part is what hanging, and both side it is hanging. That's the reason it is said double side overhanging, right? Now we have to show all the forces. So we have force. First it is 5 kilonewton. At this end also we have a 5 kilonewton. 5 kilonewton. And this is the point. Naming is also given. A, if naming is they have not given, then you have to named as per your priority, like ABCD something. But sometimes the naming they will be giving to you, so you have to follow the same naming. Okay, don't change that naming, otherwise your calculation will not be, I mean your answer will not correct. Why? Because if you have given by your own naming and they are asking calculate moment at point B and you have given your own naming, and now that B becomes E, so in that way your answer will be uh, changed. So better you have to see the beam. If naming they have given, so don't change the naming of the beam, like here it is given. So this is A, B, now this will be C, and this is E, and this is nothing but D. Okay, and here the load is 10 kilonewton from A to B. This load they have given this type of load called UDL load. This is called UDL load, right? And the intensity of this UDL load is 2 kilonewton meter, right? Now we'll write the dimension from here. So dimension, this is This is nothing but 2 meter. This is 3 meter, 3 meter, and 2 meter. This is the complete beam. Right. Now my point is for this problem, this 5 kilonewton is point load, this 5 kilonewton is point load, and this 10 kilonewton is also point load. This is called concentrated load. But what about this load, this type of load called UDL? This type of load called UDL. So I have to tell something about UDL. Now UDL is what is spread something like this. See, UDL will be spread just like a chain. Okay, just like a chain. So UDL will be spread along the span of the beam. This is the span of the beam. And if you see, span of the beam is what? It is started at point A and ended at point B. So that total span where UDL is what is spread, it is A to B. And UDL is what? Obviously it can be downward, it can be upward also. So here it is downward. So downward. Again, this UDL also few in few problems you may get something like this also. This is the beam from A to B. This UDL will be, in few books you will get this UDL something like this. This is also called UDL. The same thing. Both way you can represent this UDL. Now this UDL, as I told you, it is the load per unit meter. Like here, see the value they have given 2 kilonewton per meter. Okay. So this is what 2 kilonewton per meter. As I told you, this side it is 3 meter, and here this point is what? D, and this is also 3 meter. Check the problem. Huh? Yes or no? Check the problem. A and B, between D. Here this is suppose D. It is given only in the problem 3 meter this side and 3 meter this. Right. So whenever maybe UDL they can give in this way or they may give in this way. Both are the same. Okay. Now UDL means just like a chain. It is you just throw the chain on the table, so that chain will be something spread like this. This is the just like a chain. Okay, so it will be spread along the span. And if you check the intensity, it is given how much? 2 kilonewton per meter. Just go through the unit. Kilonewton per meter means at 1 meter total load is what? 2 kilonewton. So what is the total distance? It is 6 meter. So if you check total load, so 2 kilonewton per meter, how many meters we have here? It is 6 meter between A to B, because this UDL is what is spread between point A to B. So you are talking here between point A to B, right? Now you want to convert this UDL into point load, because if it is UDL only, so directly you cannot go for the calculation, because it is spread along the length. Once it is spread along the length, so how to calculate the moment? Because moment you have to take at particular one point, and with concentrated load only you have to write the moment, right? With UDL it is not possible to take moment. This is A and this is B. Now you are converting this UDL into point load. So first you check the intensity of the load. What is the total load? So total load, UDL, total load. See here, total load. See, 2 kilonewton per meter they said, and how total distance between A to B is 6 meter. 3 plus 3, 6 meter. So 2 kilonewton into 6 meter. If you check, I'll write with a unit so it will be more clear to you, because I'm trying to explain very basic, so you should learn this. They said 2 kilonewton per meter. You just multiply by total distance. How much it is? 3 plus 3, 6 meter. It is spread in 6 meters. So meter cancel out. How much you got? You got 12 kilonewton. Means because of this chain, what you have thrown on the table or on this along the span, so the total load because of this UDL becomes 12 kilonewton. Now this 12 kilonewton is now point load. It is fixed point load. Now where this point load will act, it is acting at point A, it will act at point B or somewhere. So the correct answer is always UDL will be acting at the mid of the span. If I say this is the point D and from D it is 3 meter this side, and from D this is 3 meter again, so it's very clear D is the midpoint. So always remember, because of this UDL, what you have converted now in point load, it becomes point load and it will act at the mid span anywhere in the any problem. If UDL is given, so two things you have to do. What you have to do first you have to convert that UDL into point load. First point, what you will do for the UDL, here I will write. First point, UDL need to convert, you will please listen, need to convert into point load, point or concentrated load, point or concentrated load. Point one, this is the point one. Second point, what is the second point you got here? Second point is that point load, point or concentrated load now act at mid of span. If I say span, it's not meaning of the mid of the beam. Span means where the UDL load is what extended, or where the UDL load is what distributed. Okay, till what distance you have to take, like here UDL is what distributed between point A to B. So now you have to take mid of AB, not mid of beam. Listen carefully. If I'm saying it will act at the mid of span, so mid of the span, so mid of span meaning is very simple, it's a mid of the distance where it is acting, where the UDL is acting, like UDL is acting between A to B, so you have to take mid of AB. So now both things you have done. You have converted UDL into concentrated load. So here I have told you how to convert. You have to write the UDL load into total distance where it is acting. So it becomes 2 kilonewton per meter into 6 meter. Meter cancel, you got 12 kilonewton now load. And now where this 12 kilonewton will be acting, it will be acting at the mid of span, means where it is acting like 3 plus 3, 6 meter UDL is what acting. So mid of the 6 meter becomes 3 meter, exactly at the mid. So this is all about UDL load. Now once you have converted this endpoint load, so now the task will be easy. Now as I told you, because whatever the beam we have, this beam is what the symmetric beam. If you check about point D, again I will draw this beam. So this beam is something like, see, this is nothing but RA, RB, 5 Newton, 5 Newton. This is D, 3 meter, 2 meter, 2 meter. At D, load is acting, point load. So point load is 10 kilonewton. Point load is 10 kilonewton, right? And because here UDL is also acting, see this A to B. Intensity of UDL is 2 kilonewton per meter. So if you check, now this UDL becomes concentrated load and it will be acting at the mid of the span. So mid of the span means exactly at 3 meter here it will be acting. So this is the point load. How much you got? 2 into 6 becomes 12 kilonewton. So this was 12 kilonewton. This is already 10 kilonewton, it is there. This is already there. So now this 12 kilonewton. So my point is, if you check this beam, point D, about point D, if you go and this side and both side, so it becomes symmetric beam. See, you can check it. Symmetric beam. symmetric beam about B. So if it is symmetric beam, then that time your reaction, whatever the reaction force, it will be equal. And it will be equal, that is one thing. But what is the another thing, how to calculate this reaction now? So total force, whatever it is acting on the beam, you have to distribute means you just make half of it. Now check what are the total loads. It's 5 kilonewton, this 10 kilonewton, this UDL you made it concentrated, becomes 12 kilonewton, and this is 5 newton. No, 5 kilonewton there. Why I have written? It's 5 kilonewton. Everywhere it's kilonewton. Now Newton, kilonewton, right? Everywhere it's 5 kilonewton. So now check this value. 5 plus 5, 10, 10 plus 10, 20, 20 plus 12, 32. 5 means 16 kilonewton both. 16 kilonewton here and 16 kilonewton here. Right? This is the way to get reaction force at point A and B. Right? At point A and B. Right. Now coming to the SFD calculation, now it will be very easy for you. So I told you how to get the SFD. So once you are going to calculate shear force, then last class I had explained nicely. You have to suppose this is the 5 Newton, so you make boundary like this. This is the easiest way. Everywhere where the forces are acting like RA, which is reaction force also, so you just make a boundary like this. Here also we have a forces, so you just make a boundary like this. Here also we have a reaction force, so make a boundary like this. And here just give the naming. This is 0 0 1 1 2 2 3 3 4 4 5 5 6 6 7 7 8 8 9 9. So if you give the boundary, then it will be very easy for you. This is the nice technique actually we are using here. So if you say 0 0, so 0 0 is what? Just before the force. What is the force here? It is 5 newtons. So just before the force is just before the 5 Newton force, is there any force? No. So that means shear force F00. F00 becomes 0 Newton, 0 kilonewton, right? But at the same time, if you go and check F11, so F11 is what? Just F11. F11. It is just after the force. So after the force means after 5 Newton. So 1 1, just you can say left or right. You can say left. This is the right to the right to the force, and this is left to the force. In few books you may get left of the 5 Newton. So left side of the 5 Newton becomes 0 0, where the value will be 0, because force is what is started after 0 0 line. So and if you check 1 1, so before 1 1 line, one force is there which is 5 Newton, and it is acting downwards. So this value will be negative because it is acting downward and in 5 kilonewton. Now coming to F22, see F22. So F22 is nothing but it's a before RA. What is the force before RA? It's a 5 Newton only. No? So and 5 Newton is acting downward, so becomes downward. F33. Where is the F33? It's a just RA. So if you are talking about just RA, just after RA, so if 33 you are talking, so how many forces we have? RA we have, and this 5 Newton. This 5 Newton is what? Downside, so minus, and this RA is what? Going upward, so this is plus. And what is the RA value? Just now you have calculated 16 kilonewton. So this value will be 11 kilonewton. Now become positive. Now we are going for F44. So what is the F44? F44 is what? Just before the that center load. So F44, if you calculate, so already we have a 11 kilonewton. okay, 11 kilonewton, and check once you reach at 4 which is just before this 10 kilonewton. So now this will be the span R and D. For F44 I will show you in this way, otherwise you may have confusion. Okay, this is very important. So for F44 I am showing you. So F44 is what, at exactly at D, just before D. So you can consider D. This is D where we are taking F44, right? And this is what, A. This point is what. So here we have UDL. Okay, so I'm showing you how to calculate for UDL. See, this UDL is what, 2 kilonewton per meter. What is the distance between A to D? See, A to D, what is the distance? It's a 3 meter. It's a 3 meter. If you convert this now downward direction, so what will be the point load? If you convert in point load, then what will be the point load? This is A, this is D, and point load will be downward, because this sign you can check, the forces are going downward for the UDL. So it will be downward 3 into 2, which becomes 6 kilonewton. Okay, and this 6 kilonewton will be downside, hence F44 will be 6 minus 6, which is downside. So UDL, because UDL will be now added between A to D, we have UDL. Okay, so that's the reason we are getting 2 into 3. I have shown you 2 into 3. 6 is nothing but 2 into 3. So now you 11 minus 6, you got 5 kilonewton plus 5 kilonewton. Now F55. Where is the F55? F55, once you talk, then this 10 kilonewton, this point load also there. Okay, so and it is in downward direction. So you got 5 kilonewton here, then minus 10, it becomes minus 5 kilonewton. Then we'll talk about the F66. Now if you talk F66, so again, as I told you, here also we have beam. See, this is now 66. Okay, and obviously this point is nothing but B, and between D to B, this is nothing but D, and this point is B. See, in between this we have UDL, 2 kilonewton per meter. Total distance 3 meters. Now if you convert in point load between D to B, so point load will be 2 into 3, 2 kilonewton per meter into 3 meter becomes 6 kilonewton. And it is also acting downward. So what you got, minus 5 kilonewton here, then again 6 kilonewton downside, minus 11 kilonewton. Okay, this is F6. What is F77? If you talk about F77 now, so we have minus 11 kilonewton and RB, because this RB is what, acting downward, which is in upward direction. So plus upward direction force will be considered positive. So 16. Again 16 minus 11 becomes 5. This again becomes positive, 5 kilonewton. Then we'll go for the 88. So what is the F88? See, before 88 we do not have any force, only 77 we have. So the same force you can write, 5 kilonewton. Then we'll go for the F99. F99 means just after 5 kilonewton. So 5 kilonewton is already we have here, and this 5 kilonewton at end we have, which is acting downward, so it becomes 0. So F99 you got. So just start and end, both we should have a 0 force. That is the cross check always. So now you are going for the shear force diagram. So for the diagram, first again you just, in short time, you just draw the beam. Roughly you can draw here. This is nothing but RA. This is nothing but RB. This is nothing but E. Okay, this is nothing but C. In between, this is nothing but D, and this is nothing but UDL load. What is the intensity of UDL load? 2 kilonewton per meter. If you, okay, dimension and all not required basically. Now, if you want to draw the diagram, then what you will do, you will extend all the points what they have given, you just extend downside. Right. At each and every points, you know the load. RA is 16 kilonewton. RB is also 16 kilonewton. Rest all places force is given. Now I told you, you have to draw one reference line you have to draw, because you are interested to in shear force diagram. So first you draw the reference line. Upward will be the positive force, downward will be negative force. Okay, I can say this line is what? 0 0 line. 0 0 means reference line. Check at point C, what is the shear force? At point C, if you see the shear force, okay, so we'll start from here. I will take black. So give the naming also. This is nothing but C, this is A, this is B, this is D, and this is what? E. Okay, right. 0 0 means it's the number, it's not a symbol, it's a number. 0 0 means it's a reference only, above positive, below negative, like that. Okay, so at C, if you check the shear force, so here we have to go. See, F11, just after the up 5 kilonewton, what you are getting? Negative 5 kilonewton. Negative 5 kilonewton means you have to go down. Negative 5 kilonewton, this is the down value. This value is nothing but 5 kilonewton. If you are going down, so don't write negative sign, it's automatically understood. If you are going down, it means it's negative. And check this point, which is nothing but AA, and all the points, if you remember, AA means here, what was the point? See, exactly at point A. AA means you are talking about 2 and 3. So just before RA, it was 2 2. So what is the 2 2 now? See, 2 2 is minus 5 kilonewton, means till this it was 5 kilonewton. This is 5 kilonewton till this moment. But what is the 3 3? 3 3 becomes 11, positive. It becomes positive now. So positive means it will go upward direction. Positive means it will go upward. So up to this it was 5 kilonewton, but here it becomes 11 kilonewton. It becomes 11 kilonewton. This is 3 3. Now coming to the 4 4. See, again 4 4, if you go, then it becomes 5 kilonewton plus, means it is reduced. Means somewhere here it is reduced to 5 kilonewton. So this line and this line, how you will meet? So because this is the UDL, and in shear force diagram, UDL you have to draw by the inclined line. So you have drawn that. Again, after D, see this numbering I am following. After D, it is 5 5. After D means you can see here also. After D, what is that? 5 5. Check. So what is the 5 5? It becomes minus 5 kilonewton. Means again it becomes negative. So this is 5 kilonewton. So the same here also you can bring this line and you can equate to this line. So this is again 5 kilonewton. This is 5 kilonewton plus, again this becomes 5 kilonewton negative. Check 5 5. It's 5 kilonewton negative. Now 6 6 again becomes 11 kilonewton negative. So 6 6 will be here somewhere. This is the 6 6. So we can draw by the dark line, because this is also UDL and this is also UDL. So whenever you will get UDL, you will have inclined line. Whenever you will have a point load or there is no load, then it is straight in case of the SFD, shear force diagram. This is again becomes 11 kilonewton. Okay, this is what is this line? It's a 6 6 line. Where is the 6 6? Again, if you want to cross check, this is the 6 6, which is just before RB. What is just RB? It becomes 7 7. So 7 7 means it becomes 5 kilonewton again positive, plus 5 kilonewton again positive. Where is the plus 5 kilonewton? Here. So again you have to go positive. This is 5 kilonewton again. Okay, right. Then 8 8 again it becomes same, and it between there is no load, so 5 kilonewton will reach here. It will be reaching 5 kilonewton here, and see 9 9 means just after. See 9 9 means just after. See after the 5 kilonewton or just after the beam is 9 9 becomes 0. So this again it becomes 0 here. Again you can come back by. So this again becomes 0. So this is nothing but SFD. This is positive. This is positive. This is negative. This is. So this is the basically shear force diagram. You can make a hash line. It will be more clear. Okay. This is the shear force.